Hello everyone, welcome to our lovely physics class. I am Nurul Izzati, your teacher for this session. Today we are going to learn about nuclear energy in 15 minutes. This is the learning outcomes for our class today. You should be able to communicate about nuclear reactions in terms of nuclear fission and nuclear fusion. Before we start our lesson, let's take a look at this picture. The sun seems to be on fire, but as far as I know, there is no oxygen in space. Something to ponder. How does the sun burn? And how does it burn without oxygen? Well, let's investigate the answer. Okay, so what is nuclear energy? Nuclear energy is known as atomic energy, released during nuclear reactions such as radioactive decay, nuclear fission, and nuclear fusion. And do you know that it can also be used to create electricity? Nuclear energy now provides about 10% of the world electricity from about 440 power reactors, and this is updated on March 2022. Just now I have said something about generating electricity from nuclear energy, isn't it? Well, how so? What reaction occurs to generate nuclear energy? Then, my friends, let's continue our lesson with nuclear reactions, which is nuclear fission and fusion. Nuclear fission. What is nuclear fission? Nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Fission can occur when a nucleus of a heavy atom captures a neutron, or it can happen spontaneously. Uranium and plutonium are most commonly used for fission reactions in nuclear power reactors because they are easy to initiate and control. Now, let's see what will happen in nuclear fission involving uranium-235 bombarded by a single neutron. So, let's say we have a uranium and a neutron here. Then, a uranium-235 nucleus is bombarded or shot by a neutron. This is uranium-236, which is the unstable nucleus. When a neutron absorbed by the nucleus, an unstable uranium-236 nucleus is produced. When the nucleus becomes very unstable, it will be broken into two smaller pieces, a krypton-92 nucleus and a barium-141 nucleus are produced. At the same time, the 3 neutron is produced and a large amount of energy released as well. Let's take a look at few examples of nuclear fission. As I have explained before, when uranium-235 atom is bombarded with a neutron, it splits into two lighter nuclei, barium and krypton, and at the same time, release 3 neutrons and 210 MeV of energy. Another example is uranium shot with a neutron and it broken into xenons and strontium, and at the same time, 3 neutrons and energy are released. In addition to that, when plutonium shot with a neutron, it will broken into xenon and zirconium, and at the same time, 3 neutrons and energy are also released. Let's continue our lesson with the pros of nuclear fission. First of all, nuclear fission can be used as a clean alternative source of energy. Nuclear fission is one of the most researched and well-known topics of nuclear technology. This has been utilized as a very clean alternative source of energy. It is also known as the energy source of the future. The second one is to fulfill the needs of the present and future generation. We know that an enormous amount of energy is produced by the process of nuclear fission, which can be utilized to fulfill the needs of next generation high-tech cities and industries. The third one is to reduce threat from greenhouse gases production and global warming. In contrast to fossil fuels, nuclear fission produces energy without releasing greenhouse gases into the atmosphere, which reduces the effects of global warming and even helps fight pollution. Last but not least, nuclear fission is extremely low operation cost. The cost of operation is very low once the nuclear power plant is commissioned. The costs in operation are only the payment of workers to run the plant and the cost of the raw materials required. Well, we have seen enough of the pros of nuclear fusion. Now, let's move on to the cons. First of all, nuclear fission can contribute to a higher risk of radiation exposure. The radiation emitted during the fission reaction is extremely harmful to humans and animals. The workers who are exposed while working at nuclear power plants are at great risk of radiation poisoning, cancer, and other diseases associated with radiation. The second one is high vulnerability. High vulnerability is a potential risk that is involved in nuclear power plants. The enormous energy produced in a fission reaction can be utilized to create nuclear weapons. Any small accidents at a nuclear plant can cause huge damage, affecting the lives of millions. The third one is radioactive contamination risk. The waste that is released from the nuclear power plant is highly radioactive and harmful for all living beings. There are high chances of water contamination from these plants, which can cause serious disease and death in living beings. Last but not least, the high cost of plant commissioning. To build a nuclear power plant requires a huge investment, and this is due to the latest technologies and safety measures that are required to run it properly. Let's move on with our second topic, which is nuclear fusion. Nuclear fusion is a nuclear reaction in which a small and light nuclei combine to form a heavier nucleus while releasing a large amount of energy. This nuclear reaction happens under extremely high temperature and pressure. Nuclear fusion uses lighter elements such as hydrogen and helium, which are in general more fusible. These two are the examples of isotopes used in nuclear fusion: deuterium and tritium. Now, let's see the process of nuclear fusion between deuterium and tritium. Here, we have deuterium and tritium, and they are isotopes of hydrogens. When we have two atoms or two nuclei, then we combine them together. Therefore, the process of fusion will occur. After the reaction, it produces a neutron, helium, and a large amount of energy is released. In conclusion, nuclear fusion occurs when we combine or join two nuclei together to form a new heavier nucleus. Here are a few examples of nuclear fusion. Deuterium-deuterium fusion will produce 3.27 and 4.03 MeV of energy, while deuterium-tritium fusion produces 17.59 MeV of energy. However, deuterium-helium-3 fusion will produce the highest energy release, which is 18.3 MeV. And now, my dearest friends, let's continue our lesson with the pros of nuclear fusion. First of all, nuclear fusion doesn't create harmful waste. Helium, which is the byproduct of nuclear fusion, is non-toxic, safe, and won't create the same environmental damage that the burning of fossil fuel creates. The second one is there is an infinite amount of fuel for nuclear fusion. The main ingredient of nuclear fission, which is deuterium, is distilled from ocean water. Every other component of the process is either easily found or easily made. The end result is an infinite amount of fuel that can be used to create energy resources for the entire planet. The third one is, it is incredibly inexpensive to create. The estimated cost of providing energy through nuclear fission is just 3 cents per kilowatt hour. This makes it one of the cheapest forms of energy that humans have ever discovered. Last but not least, the global warming can still be negated without energy loss. Helium is not one of the greenhouse gases that are believed to be contributing to changing weather cycles. This means the planet can continue to heal and we don't have to sacrifice energy levels to make that happen. Now, let's move on to the cons of nuclear fusion. First of all, the difficulty for achieving the fusion power. In the sun and stars, high temperatures and powerful gravitational force naturally prepare a fusion environment. But here on our planet, we face the challenge of making nuclear fuel hot and enough limitations to begin a self-sustaining ignition. The second one is more research and brain power is needed to solve its issues. To make fusion work, enough intelligent mind needs to cooperate to address and solve its challenges. Last but not least, its practical energy returns are still quite unreachable. Existing methods for artificially igniting nuclear fusion still require large amount of energy input, even on a small scale for a brief moment. Now, let's have a look at this video. Did you enjoy the video? Now, let's conclude the similarity and differences between nuclear fusion and nuclear fission. For the similarity, both are the nuclear reaction that produce energy from atoms. And for the differences, let's take a look at this table. Nuclear fission, by definition, is the combination of two or more atoms to create one large atom. And for the nuclear fission, it is the division of a larger atom into two or more smaller atomic particles. The examples for the nuclear fission are deuterium and tritium of hydrogen in helium. As for nuclear fission, the examples are uranium-235, plutonium-239, and radioactive decay in unstable isotopes. Nuclear fission naturally occurs in stars, such as the Sun, while for nuclear fission, it does not occur naturally. Nuclear fission's energy production. Reactions of light nuclei produce a very high energy, whereas reactions of heavy nuclei may not release energy. For nuclear fission, it produces a high energy production. What is the requirement for the nuclear fission? It requires a high temperature and high pressure condition. But for the nuclear fission, it may require high-speed neutrons. Let's go back to our first question. How does the sun burn? How does it burn without oxygen? Actually, the sun does not burn. The sun glows because it is a very big ball of gas, and a process called nuclear fusion is taking place in its core. Nuclear fusion occurs when one proton smashes into another proton so hard that they stick together and release some energy as well. The nuclear fusion does not involve oxygen at all. This energy then heats up the other materials, which is other protons and electrons and such nearby. This heating eventually grows out from the center or core of the star to the outside, finally leaving the surface and radiating out into space to be the heat and light we know stars emit. Now we know the answer. Now, my friends, let's test your understanding. Below are the few questions that you can try, and I believe you can do this. That's all from me. Thank you, and have a nice day.